Okay. Good evening, guys. Hi, Dhruva, Swaroop.
Good evening, sir.
Okay. So today we are going to study the next topic, capillary action. Capillary action. Okay. So what is capillary? Capillary, it is a small, okay, very tiny tube, okay, open at both end. Have you seen that normal straw which we sip cold? Have you seen?
Yes.
It will be very thick. You can divide it into three parts. If you divide the length, the breadth into three parts, that small it will be. That will be the length. Maybe hardly this much. So open and so basically it's like a tube. It's like a cylinder tube, open at both end. Okay, but the radius of this cylinder basically. When I say the radius is very small, maybe it's the order of 0.5 millimeter. Clear? The diameter is the order of 0.5 millimeter. Understood?
Yes.
What we have to do, if one end of the capillary is dipped in the water, if you take a vessel and you put the capillary inside the water, there will be, depending on the type of water, there will be a rise or fall. Means the water will either rise, okay, or the water will, not the water, liquid will fall. Fall means the liquid will be here. Did you understand, guys? So this,
Yes, sir.
the water will gush inside, will go inside up to certain height, or the liquid will fall. That means this part will be empty, though the level of water is here, but this part will be empty. And this part is called capillary rise, and this one is called capillary fall. Is it clear? Is it clear to all
Yes.
of you? So we are going to see what are the examples. Okay, so you can write one sentence. The phenomenon of rise or fall in liquid. The phenomenon of rise or fall in liquid. The phenomenon of rise or fall of a liquid inside a capillary tube when it is dipped in the liquid. When it is dipped in the liquid is called capillarity. Is called capillarity. Again, I am dictating. The phenomenon of rise or fall of a liquid inside a capillary tube when it is dipped in the liquid is called capillarity. So capillarity is basically an action. Capillarity is a verb. It relates to action. What is the action? Either the liquid will go inside, rise, or the liquid will fall. This rise or fall of the liquid is called capillarity. It's a phenomenon of rise or fall of liquid. Is it clear? Is it clear?
Yes, sir.
So what are
Yes, sir.
what are the various examples? The first example is, if you have seen, I don't think now it is available, but when I was in the village, we used to have lanterns. Okay, lanterns, and there will be a lamp. Small
Yes,
kerosene.
sir.
Okay. So where there will be a small wick, there will be a wick, and there will be a dabba where they'll put kerosene, and the wick will have a will go inside. You tell me, the the kerosene is only till this much, but how come the water is rising, the kerosene rising? It is because of the capillary action. Did you understand?
So is it
Because
not because
it's not because of
the cotton has a it can absorb liquids, right, sir? So is that
yeah.
not the correct reason?
It is because of that only. Exactly, it will absorb, obviously. But what is the action? It is the capillary action only. Rising, no, liquid is rising, right? So the
Yes, sir.
wick is basically what? A cloth where you have some pores. Yes or no?
Yes, sir.
The kerosene is here. So basically, one is it is absorbing. So absorbing means what? Why it should go up? It is the capillary action only. The pores act like a same like a capillary tube. Okay. So the first is the oil rises. The oil rises up in the wick of a lamp. That is first example. Second example, you take a gunny bag. You take a gunny bag. You dip into the water and keep it. You see, slowly the water will rise, and you will see though water is here, the level is here. Till this much, it will be wet. Yes or no? Have you seen? It will become
Yes,
wet.
sir.
Why? It is again the capillary action. Understood?
Yes,
Water
sir.
rise. Also, you take some rock, you put it in the water, you will see slowly the water will rise. You will see till this much the rock, it will be again wet. This is also capillary action. Understood?
Yes, sir.
All these are, and one more, the best example is, tell me what is the best example? Uh,
Straw.
no, straw, so you are blowing. Uh, no, I think that's all. So when a capillary is dipped in a liquid, two effects are observed. What we see, one is the rise and one is the fall. So rise and fall doesn't happen for same liquid; it happens for different type of liquid. So we are going to discuss each one of them. Okay. First we'll understand what is capillary fall. Okay. So what we will do, we will take again a vessel. We will put mercury, and we have a capillary. You know very well what is the, if the mercury is dipped, so how will be the meniscus? The meniscus will be concave. Yes or no? Concave meniscus.
Yes, sir.
So this will be a concave meniscus. Okay. So what we will do, we will take 4 points. This is the A point, this is the B point, this is the C point, and this is the D point. Okay. So this part of the part which is below this one is the concave part, and the above part is the convex part. Okay. So point A is the convex part of the capillary. Point B is the concave part. This is the convex part. The C is this basically a plane plane surface. Yes or no? Plane surface. This is the
Yes.
top part of the surface, and this is the exactly below the bottom part. Is it clear? So now at
Yes, sir.
each point A, B, C, D, you will have pressures. So at point A it is PA, at point B it is PB, at point C it is PC, and at point D it is PD. Okay. So pressure at each of the points. Now you tell me, when we discussed about this meniscus, do you remember that the pressure at the concave side is always greater than the concave side? Oh, sorry, convex side. Yes or no? You would have remembered, we discussed about this
Yes,
concave
sir.
versus convex. So that means the pressure at B is greater than pressure at A. Always the concave part is greater than the convex part. Understood? Now, A and C are at the same level. A and C are at the same level, and C and D are very close to each other. They are very close to each other. So the pressure at C should be equal to pressure at D, and the pressure at A will be equal to pressure at C. Why? Because they are at the same level. Yes or no? Yes or no?
Yes, sir.
So can I say the pressure at A is equal to pressure at C is equal to pressure at D? Yes or no? So pressure at A, C, D are same. Then what will be, what happens to B? What happens to B? If I say the pressure here is more, if the pressure here is more and pressure here is less, okay, then if the pressure, if you compare pressure at here will be greater than pressure here. Yes or no? Pressure at B is greater than pressure at A. Pressure at A is equal to pressure at C is equal to pressure at D. So that means the pressure at B is at a higher point than all these points or not. And you very well
Yes,
know,
sir.
that whenever something high pressure is there, the liquid will flow from the higher pressure to low pressure. If the point B is at high pressure, what will happen? Immediately the liquid from here will go below, and the liquid level will fall down. Did you understand? Did you
Yes,
understand?
sir.
In order to maintain the pressure, all the cyclone, what is the main funda of cyclone? What happens to cyclone? Cyclone is basically what happens, that the water, the air from the adjacent area, high pressure area will gush immediately to a low pressure. Understood? And whenever it happens, whenever a low pressure is created, okay, immediately the air from the high pressure area will go to the low pressure. Is it clear? Is it clear?
Yes, sir.
हाँ? Hence, क्या हुआ ऋषभ? नेटवर्क इशू है क्या?
हाँ सर.
Okay. So pressure, immediately the water, since this water is at high pressure, all the water here will go below, will fall down, and that's how the pressure becomes equal. After some time, the pressure at each point will be equal. Did you understand, guys? Did you
Yes, sir.
understand? All of you? All of you understood? So this is the concept of capillary fall. Now we will come to capillary rise. What is capillary rise? Again, capillary rise, we will take water. Initially, the water, what type of meniscus it is? What type of meniscus?
Convex
Convex.
meniscus.
So again, we will take 4 point, A point, B point, C point, and D point. Okay. Now you know that convex meniscus, this pressure is lower, this pressure is higher. That means PA is greater than PB. Yes or no? Yes or no?
Yes, sir.
And what else? And what else? PB is equal to PC is equal to PD. Yes or no? Pressure at here,
Yes
here,
sir.
and here are equal. Pressure here is more. Yes or no? Pressure here is
Yes
more.
sir.
So what will happen? Now you see, if you enlarge this, can you see a dip here? Pressure here is more. But what about here? What about here? Here the pressure is less. This part is the pressure is less. So what will happen? When the pressure here is less, immediately the water will flow up and will rise till the pressure becomes equal. After some time, you will see that the water will rise. Did you understand, guys?
Yes, sir.
All of you clear? All of you clear? Because there is a convex
Yes,
meniscus.
sir.
Convex meniscus, this part is the convex part which has the lower pressure. And you very well know when this is higher pressure, immediately water will gush to equate the pressure. And we will have to find till what. So we saw that water will fall and water will rise. But till what amount the water will rise and till what amount the water will fall, this is what we are going to find out the what? Find out the length. That means if I say that water will rise, then what distance the water will rise? What distance the water will rise? H. So what is this H? We are going to calculate. We are going to calculate. Okay. So we will understand that there are two methods. We will calculate the this how much would be the rise or how much would be the fall. So that is called the expression for capillary rise or fall. So we will first method we will use the using pressure difference method. So now, guys, remember in the last class we had understood no explanation of drops and bubbles where we calculated one formula pi minus p naught equal to 2t by r. Yes or no? Yes or no? In the last class, guys,
Yes.
yes or no? So if I consider a capillary, okay, let's say this is the convex. So is it not like a circle? Is it not like a circle?
It is like a circle, sir.
So if I say there is a point curvature, that means this one, and this one are nothing but the radius of the whole circle.
Yes, sir.
Yes or no, all of you? And if I say that
Yes, sir.
if the liquid is like this, so it is like what? It is like a hemisphere. Yes or no?
Semicircle.
Not semicircle, hemisphere. It's a three-dimensional, no? The capillary is three-dimensional. It will be a semicircle. So semicircle will have a radius. This radius will be there. No, this circle has a radius. See,
Yes,
there are
sir.
two things. This circle has a radius, and this circle has a radius. If it see you have a big sphere. If I cut it immediately in the half, then this radius will be equal to this radius. Yes or no? Yes or no?
Yes, sir.
But what say if I am cutting the sphere from here, then this radius is not equal to this radius. Yes or no?
Yes, sir.
Yes, sir.
Do you understand what I'm trying to say? If you're cutting it immediately in the half, then the radius here and this radius is equal. But if I am cutting it somewhere here, then this radius will be smaller. We don't know. We can't say that this radius will be equal to this radius. Yes or no? Yes or
Yes,
no?
sir.
Yes.
So we are going to find out. So if I say that this is the point of the curvature, then this is the radius. Yes or no? Yes or no?
Yes, sir.
So what we will do, we will find the relation between this radius and this radius. Which radius? What is this one? Angle of contact. Yes or no?
Yes,
And
sir.
this is the radius. Because why? Because this is a capillary. Capillary, this radius is same as this radius. Basically, the radius of the tube. Yes or no? It's a cylinder basically. Yes or no? Cylinder,
Yes,
cylinder.
sir.
This radius will be, if you draw here, all these are radius. Yes or no? Yes or
Yes.
no? So
Yes,
we have
sir.
to find out what is the relation between this small r and this capital R. And this theta will be equal to theta. Why? How? Can somebody tell me how this angle is equal to this angle?
Adjacent angles are equal.
Adjacent angle. How it is adjacent angle?
Sir, it's not adjacent, but it's near to that end. It's joint.
How it is adjacent? This is your homework. You have to tell me in the next class. Okay? How these two angles are equal. Okay? So
Yes, sir.
Yes.
this, so now you know this relation. I'm deleting it. So now we have to find if this is theta. So this is like a right angle triangle. Yes or no? This is like a right angle triangle, and this is R, this is R. So can I say, if I turn this triangle this side for your all understanding, better understanding, can I say this is R and this is capital R? Yes or no? And this is your angle theta. What will be your cos theta? Your cos theta will be what? What will be your
1
cos
by
theta?
side.
Base by hypotenuse. R by capital R. Yes or no?
Yes, sir.
Yes or no, Rishabh?
Yes, sir.
Vash, Swaroop? Is it clear?
Yes,
Correct.
sir.
Huh?
Yes, sir.
Then can I say your capital R is nothing but R cos theta?
Yes, sir.
And you know that this relationship is equal to 2T by R. And this is what type of pressure it is? It's called gauge pressure. Yes or no? Gauge pressure. And you know very well that gauge pressure is given by H rho G. That means H rho G is equal to 2T by R. Yes or no? All these we studied in the
Yes.
previous class.
Yes, sir.
So now we are going to substitute. Very carefully see what we are going to do. All these I am deleting, not required. So H rho G is equal to 2T by R. R equal to R by cos theta. So can I say 2T by R by cos theta? So can I write 2T cos theta by small r? Yes or no?
Yes, sir.
Yes, sir.
So H rho G is equal to 2T cos theta by R. So can I say H equal to 2T cos theta by rho G R? Yes or no? Yes
Yes.
or no?
Yes,
Yes,
sir.
sir.
So what did you see? We have eliminated that capital R. Why? Because we don't know. We only know the capillary. We only know the radius of the capillary tube. We don't know how the meniscus will be. Meniscus can be like this, or meniscus can be like this, or meniscus can almost like plane. Yes or no? This is unknown. So what is known to us? What is known? What is the surface tension of the liquid? What is T? T is the surface tension. What is the angle of contact? Because you know very well, for each liquid, you know what is the angle of contact. You know what is the R, what is the radius of the capillary, because you only are getting it, right? And you know G. G is obviously, it's a constant. And you know the density of the liquid. Did you guys understand? Did you guys understand? So what will be your height? Your height will be 2T
Yes, sir.
cos theta by rho G R. This is your formula. Very, very important formula. Capillary rise or capillary fall. Now, you tell me how we can say that capillary rise can be there. When I am saying capillary rise can be there, your theta has to be what? Acute. Yes or no? Yes or no? Whenever the convex is there, Your theta is acute, yes or no? And whenever
Yes,
acute
sir.
angle is there, then only the theta will be high. Sorry, there will be a rise. So if the theta angle is acute, then your H is positive and it's a rise. And if the theta is what? Obtuse. Obtuse. If theta is obtuse, then cos theta will be negative. Yes or no, Rishabh? Swaroop?
Yes,
Yes.
sir.
Theta is obtuse. Theta is obtuse means how the meniscus will be like this. That means like this. That means this will be theta. Theta is greater than 90. If theta is greater than 90, second quadrant cos theta negative. Cos theta negative means H will be negative. Did you understand? And it's a fall case.
Yes, sir.
Is it clear to all of you?
Yes, sir.
So you will
Yes, sir.
say that if you want the so there are various parameter. Either you can increase the surface tension, use a liquid which has a higher surface tension, less angle of contact. So you can play around. Understood? Narrower the tube, more thinner the tube, rise will be better. More smaller the R. Why? Because arch, H and the radius of the capillary are both inversely relationship. Thinner the capillary, better, higher the rise. Fatter the capillary, the rise will be less. Yes or no? Yes or no? Huh? Yes or no?
Yes, sir.
Swaroop, where are you?
Yes, sir.
Swaroop, what happened? Harsh,
Yes, sir. Yes, sir.
clear? Very, very important. Okay. Now we will go to the second method. Second method. Second method has 5 minutes. Can you guys do one thing? Join, rejoin, no?
Okay, sir.